Passive House is the leading international standard for high-performance construction, with more than 100,000 buildings worldwide. People are enjoying the comfort and efficiency of Passive House buildings in all climate zones, from Sweden and Germany to Sri Lanka, Dubai, and China, and across North America. The Passive House standard was created in the early 90s based on scientific research that concluded comfort drives performance. In the process of dramatically improving comfort, application of the Passive House principles also resulted in up to 90% reduction in the energy required for heating and cooling, and up to 75% reduction in the total operational energy use of buildings. Historically, almost all of that energy was derived from the burning of fossil fuels and has been a major contributor to CO2 emissions. In an effort to drive down those emissions, an increasing number of countries, regions, and cities are adopting the Passive House construction standard in order to support their transition to a fossil fuel-free energy grid and reach carbon neutrality. Those places include the province of Brussels, British Columbia in Canada, the entire country of Luxembourg, the cities of New York, Dublin, and many others. It is important to point out that Passive House is climate specific, since even if the standard is setting worldwide energy targets for heating, cooling, and the total energy consumptions, the ways to achieve those targets differ dramatically based on the local climate. A simple but comprehensive energy modeling tool, called the Passive House Planning Package, or PHPP, allows design teams to identify and select appropriate solutions for their project based on location, building design, and performance goals. Another important reason why jurisdictions are embracing Passive House around the world is the proven accuracy and the high correlation between the expected performance and the actual performance once the Passive House buildings are completed. The PHPP delivers reliable performance with no performance gap. The 5 basic and inseparable key principles of Passive House are an airtight building envelope, strategic insulation correctly applied, analysis and management of thermal bridges, high-performing windows and doors, and continuous balanced ventilation. What does all this mean for us here in California with our mostly mild climates? California was the first state to implement minimum energy requirements in 1974, and California's construction code remains today one of the most advanced codes in the country. Unfortunately, due to several ambiguities and loopholes, our construction code is not built to identify a defined end performance goal or move fast enough to avoid compromising our future and the future of the planet. Building codes are intended to set a bare minimum level of safety and performance. They work to prevent catastrophic failure at the bottom, not to define optimized outcomes. The PHCA community already knows it's possible to build much more comfortable, healthier, and better performing buildings with little to no impact on the investment required, especially here in California. A positive factor in California is our transition initiated away from natural gas to all electric. This decarbonization shift aligns perfectly with Passive House because the first step in decarbonization is to maximize efficiency. The Passive House Standard's Primary Energy Renewable (PER) framework goes one step further to optimize building designs to support a 100% renewable energy grid. Let's review the 5 key principles of Passive House and look at how they work together to provide a unified, integrated systems approach to the designing of buildings. The first 4 of the principles have to do with the building envelope, that is, the boundary between the inside and the outside. Passive House Principle Number 1, Airtight Building Envelope. The most dramatic difference between a Passive House building and a standard Title 24 code construction is the airtightness of the building envelope. Because California does not require air tightness testing, the most significant loss of heat in winter or cooling in summer takes place through small gaps in your floors, walls, and roof. By applying the Passive House air tightness requirement, a 20% improvement in energy saving would be made in local construction. To illustrate the potential gains, for a 2,000 square foot, 2-story house, the equivalent hole from the blower door test result is about a 5-inch diameter. Today, most California's new construction of the same size have the equivalent of a 16-inch diameter hole. How do you expect to keep a place cool or warm and comfortable with a window open 24/7? Passive House principle number 2, strategic insulation correctly installed. Strategic insulation means a systematic plan for insulation throughout a building that is correctly installed. In the mountains of California, we have cold winters and we experience some very hot days during summer in the valleys. But throughout most of the state, we enjoy a relatively temperate climate. Using the PHCA enables us to specify appropriate insulation for under the floor, within the walls, in the attic and/or roof, and often also a slim layer of 1-inch or 2-inch, not 16-inch in California like it can be in Minnesota, of continuous insulation on the exterior of the walls. This system of strategic insulation is a critical factor in achieving the drastic reduction in energy required for heating and cooling for a Passive House building. Passive House principle number 3, avoid or minimize thermal bridging. A thermal bridge is simply a break in the insulation, like for example a beam going from inside to outside a building or the connections between the floors and the walls. That break in the insulation allows the heat to escape the building during the winter or to get into the building during summer. While intuitively this may seem insignificant, the amount of energy losses can be substantial. These thermal bridges drastically increase the risk of creating condensation and mold and potential damages to the building structure. Therefore, they need to be avoided or minimized as much as possible. Studs, beams, or concrete slabs that create breaks in the continuous insulation are the most common thermal bridges. It is important to avoid them whenever possible, using specific design details and thermal break products and materials. Paying attention to design details and installing a layer of continuous insulation, as mentioned earlier, on the exterior walls are the most common practices to avoid thermal bridges. Passive House principle number 4, high-performing windows and doors. Windows and doors are the weakest points of the building envelope, and it is important that they too are high-performing. While triple-pane windows are required in many locations to meet the Passive House energy targets, in most California's locations, double-pane windows will work perfectly. But energy-efficient ones, which means we need better, thermally insulated frames, high-efficiency glass, and ensure these are airtight. A house, or any building, is a system, and the windows and doors are parts of that system. The detailed modeling of PHCA enables the specification of windows and doors appropriate for the overall performance goals associated with Passive House, including how they are installed. Windows can also help to heat your place in the winter, but they also can make your place overheat in the summer. Therefore, placing and choosing your windows is crucial, and shading is also a key aspect of the design strategy. Shading by trees, fixed architectural elements, external blinds, but always external shading. Internal shading is far from being as effective. The heat is already in the building. It is too late. Now you can sit by the windows during the winter or summer without being uncomfortable. We've just made your place bigger without increasing the square feet. Passive House principle number 5, continuous ventilation, generally with heat recovery. Houses don't need to breathe, but the occupants do. In order to provide continuous filtered fresh air, a passive house requires balanced mechanical ventilation. A steady flow of fresh and filtered air is supplied to the living spaces 24/7, and at the same time an equal flow of air is extracted from the home, generally from kitchens, bathrooms, and the laundry room. This continuous exchange of stale air for filtered fresh air is critical in pandemic times and reoccurrence of smoke from wildfires in California. Healthy indoor air quality is another important benefit of passive house standards. This balanced exchange of air is accomplished most of the time with a heat recovery ventilator, HRV, that transfers the heat from the outbound conditioned air and transfers up to 90% of that heat to the incoming air. In summer, the HRV works the opposite way. The fresh air coming in will be cooled down by the exhaust air going out. Also important, the HRV accomplishes the transfer of heat without mixing the outbound and incoming air. As you can see, passive house is not rocket science. It is mostly just changing priorities based on common sense. Passive House California has been advocating for the passive house standard since 2007. A 2016 study demonstrated the gains for a single-family passive house compared to standard construction. Depending on the California climate zone, the heating and cooling energy savings would range from 40% to more than 80%. That is huge savings. A 2019 study based on a California Energy Commission multifamily prototype and validated by the California Energy Codes and Standards team even went further, demonstrating the benefit of the passive house standard over the Title 24 code. At the Net Zero Conference 2018, an icebox challenge between a passive house box and a Title 24 box dramatically illustrated the superior performance of passive house. In each box, we put 500 pounds of ice. At the end of the challenge, after 7 hot days, 61 pounds of ice was left in the passive house box. In the Title 24 box, all the ice was gone more than 24 hours before the end of the contest, and the interior of the code box was much hotter inside than outside. The reduction in operational energy related to the implementation of the passive house standard enables net zero energy with as little as half the solar panels and doubles the impact of battery storage. California's PV requirements for residential construction can be achieved with a significantly lower investment. This is not the smart way to get net zero energy. California was the first state that committed to all renewable energy by 2045, but renewable energy from solar and wind are variable based on time of day, weather, and time of year. Therefore, we will need a massive amount of energy storage in order to provide sufficient power overnight and across the seasons. Because of the seasonal storage losses, it is necessary to produce 2 to 3 times more energy than required for the building operation. So every kilowatt per hour saved by the efficiency of a passive house reduces demand from the production or storage in the same proportions. Reducing our energy consumption is a key aspect of the successful transition to renewable energy, and the efficiency of passive house buildings is part of the solution. A substantial contribution indeed. The Passive House Standard has 3 certification classes. Passive House Classic is the original and was developed based on comfort and efficiency. An airtight and well-insulated envelope was the foundation. Orientation and shading to manage solar heat gain further enhanced both comfort and efficiency, and balanced ventilation with heat recovery provided continuous fresh air with little heat loss. In 2015, Passive House Classic was joined by Passive House Plus and Passive House Premium in order to integrate solar PV into the Passive House standard. Passive House Plus requires enough solar PV to reach net zero energy, and Passive House Premium requires significantly more solar PV and can approach net zero carbon. In 2012, because existing buildings are a huge part of the energy consumption we need to reduce, the Passive House Institute launched EnerFit, a standard and subsequent certification for the optimal application of Passive House protocols to the retrofitting of existing buildings. The EnerFit standard provides a comprehensive approach to achieving the highest levels of both comfort and efficiency at an appropriate level of investment and will play an important role in the mitigation of climate change. The Passive House Standard is a globally applicable reference tool for energy consumption and comfort, addressing the main part of the building's CO2 emissions during its life cycle. Passive House for energy efficiency and comfort of buildings is foundational and works in synergy with environmentally and socially responsible buildings rating systems. This is why building certifications such as LEED from the USGBC or the Living Building Challenge from ILFI encourage the use of the Passive House Standard for the energy part of their programs. Among those major additional issues, the Passive House Institute strongly supports reducing the CO2 emissions related to the construction of buildings, especially by avoiding foam-based insulations and favoring biosourced construction materials. Many steps need to be made towards a carbon-neutral future to mitigate climate change. According to the most recent IPCC report, we need to reduce our CO2 emissions by more than 50% by 2030. Adopting the Passive House Standard for new construction and the EnerFit standard for major renovations are important steps in that direction. The Passive House Standard is applicable to any and every building, whether single-family houses, multifamily apartments, high-rise buildings, hotels, schools, office buildings, supermarkets, fire stations, museums, hospitals, swimming pools. Designing and building or renovating to Passive House standards is a positive step for the occupants, owners, communities, and planet. Many of these buildings can be visited in California and around the world during the Passive House Open Days. More information about Passive Houses near you on our website, www.passivehousecal.org. Contact us, join us, get trained. We need you. California needs you. Our future needs you.